Hey there, I'm Alex. A few months ago, I covered Trellis, which is an image to 3D or text to 3D asset generator. There's been some updates in the space, and I finally think there is a new one that is actually worth moving on to. I used Trellis quite a bit for the last few months. In my opinion, this model is so much better than Trellis is that I wanted to do a video specific to it to show you what you can achieve with it. The model in question is Hunyuan 3D version 2. Some of you might know that Hunyuan 3D had a version going around for a few months. It was okay. To me, Trellis always generated better results than Hunyuan 3D, but now that they came out with the version 2, I find it to be so much better that this is where I leave Trellis behind. Today I'm going to be using Hunyuan 3D on Comfy UI directly, but do know that you can use it on Pinocchio. So if you just go to pinocchio.computer, you'll see that they have a Hunyuan 3D option. A few weeks ago, I actually downloaded it on Pinocchio, and the results were weird, and I was getting all sorts of issues that I thought it was a model problem more so than my installation. So I uninstalled it and I moved on, and I just kept using Trellis. A few weeks went by, and then I saw a Reddit post of someone that was having a very similar experience in Pinocchio with the Hunyuan 3D installation, and I decided to just take the plunge and do a Comfy UI install specifically for Hunyuan 3D. It's important to note two things. The vast majority of people are having a great experience using Hunyuan 3D on Pinocchio, so it must be something with my hardware or my OS. But if you do decide to go the Comfy UI route, I would recommend that you install a fresh Comfy UI install only for this. The reason for that is that if you read about this and how it's installed in Comfy UI, it might break a bunch of things and render your Comfy UI installation useless. So definitely do an alternate installation of Comfy UI specifically for this. At least that's what I would recommend. I did it on a brand new Comfy UI installation, and there were a few hiccups here and there to get it running properly, but in the end, it was so worth it, and I'm so happy that I'm going to be able to show you what it can do. If you install Comfy UI right now and update it to its latest version, what you'll find is that it is already compatible with Hunyuan 3D out of the box. However, the implementation that comes with Comfy UI is okay at best. What you really want to be downloading or adding to that Comfy UI installation is a Comfy UI Hunyuan 3D wrapper by Kijai. There are detailed installations on how to get this installed directly in Comfy UI here on the repo itself, but it should be fairly easy to get up and running. Once you do have it running, what you want to do is you want to come here again to the repo and then come here to the example workflows folder, and then once you open that, you're going to find three options, but what you want to grab is the last two. If you look here on the right, what you'll see is that those are the ones that have been updated recently. Once you have Comfy UI up and running and have the wrapper installed, download that first workflow and you're going to be presented with something like this. The first workflow I'm going to be talking about is the example 01 here on the wrapper repo. I'm going to go back to Comfy now, and once you bring it in, it's going to look very similar to this. I've made some slight modifications just for myself, and I've added some notes so that I know what does what. Okay, so you want to start by going to the top left here, and you're going to have a load image. So what I've added to my workflow here is just an image of a fire hydrant. It happened to have an alpha channel all embedded by sheer luck when I was Googling for images, but you don't really need a cutout. The workflow itself already has a background remover already embedded in. So if I go ahead and I select this mask preview, right click and Q select it, just so I can show you, it's already going to remove the background of your input image, regardless of it having an alpha channel or not. So you can basically ignore that. Important to note that for resolution, it looks like this model likes 518 as an input. So no matter what you plug in here, it's always going to be resized here at the beginning, and you'll find that some of these notes are scattered through the workflow added by the person that put this together, and there are some others that I added for myself. But it's a good idea that you read the ones that are there so that you can understand more or less what's going on. The 518 here, it's something that you should really not touch. I tried touching it to see what happened. I couldn't see any increase in quality at all. So it looks like it just plays with that resolution, and that's it. However, once we get to the texture generation, you'll see you have some freedom. So moving on here to the right, what you'll see is, again, this is where the background gets removed. You'll get a preview, make sure that everything looks okay. If you wanted, you could also just, remove the background somewhere else and then just input it yourself by hand here, and that would essentially bypass this. Once you have that, make sure that you download all the models. You'll find notes here on the workflow as you go along, so you make sure you download that, you put that in the correct place. And if you try to run the workflow, you'll see you'll get red notes wherever the nodes aren't either loaded correctly or downloaded yet. So just make sure you grab those as you go along the workflow and start reading the notes that are already there. A few things to note here for the mesh generator. Guidance scale, as I have here on my cheat sheet, is always a good starting point to start with 5.5. The lower you go, the more freedom you give the model to generate something slightly different from your image. And the higher you go, the more you press it for it to stick closely to the image you've provided. I rarely deviate from 5.5, but I figured I'd let you know that's what that's doing. I believe the steps come at a lower quality by default, somewhere around 30. I found the sweet spot for me is around 50 or 60, so I just leave it at 50 as a default for myself. And then I like to keep the seed fixed just so that if I need to generate other things in the workflow, the model isn't generating every time I make a run of the workflow. However, if you think the output model is not good enough or something's weird about it, make sure you just, start moving around the seeds and try different ones until you're happy with the model, and then move on with the rest of the workflow. Moving here to the right for the VAE code, the octree resolution comes lower by default. I found 512 or 768 to be the sweet spot for myself. In theory, the higher you go, the better results or the better model you'll get. It will make your processing times longer though, so just something to keep in mind. Finally here on the post-process mesh, there's a couple of things that you should know about. Mainly, the max face num is the max number of faces that the model should have. So it grabs the output from the decode and then makes sure that it reduces the numbers up to the number that you give it. So by default, it comes in at 50,000, I believe. I've gone with denser meshes, but 50,000 seems to be a pretty good starting point. Another thing to keep in mind here is that you have a few options. All of these should be turned on because it's just going to create a cleaner mesh. And then at the bottom, you have smooth normals, which you can turn on and off, but we can add a little switch for this at the very end of the export if you like. So by default, it comes off. If you wanted to add it, you can either do it in the 3D program or you can do it either here or later in the process. I'll show you where. Once you have that, there is the first export mesh here. I leave it by default on save file. It doesn't really matter. I'm not going to be using it, but I'd rather know that it's saved as I go along my workflow and I can just scrap it in the end when I get my output OBJ. I leave it on and I leave GLB just because GLBs have embedded textures, and that's something just very nifty because just with one file you have both things so that you can preview them properly. If I click here on the preview 3D and I say queue selected, what's going to happen is the processing is going to start up to that point in the workflow. So I'm going to open my command line here just so you can see. And you'll see after a few seconds, it goes through, it removes the background, and then it starts processing the mesh for us. And then finally, we'll get a preview here in the window. So that took, 40 seconds to complete. 40 seconds. And this is not too bad. So I have a preview set to normals just so that I can see what's going on with the model. And considering we only gave it one image, let me just bring this image here just so that we have it for reference. I think this is pretty damn good compared to what we had before. Again, it's doing all the guesswork of what's going on behind. And granted, this is not the most complex of models, but this is not something that you're going to be using for hero models, right? Like we're nowhere near there yet. But for props, for background elements, like there's just so much you can do with this because there is clearly a quality jump from Trellis to this. So I'm going to zoom back here and just let me show you a couple of things. So you can, by default, open here some options and you can either change the lighting or you can just go back to model and select I want the original. So you can just look at the gray mesh, right? Sort of like a Lambert shader, or you can just look at the wireframe. And again, this is set to 50,000 faces maximum. If we wanted, we could increase it to a higher density, but for a prop like this is more than enough. I'm going to zoom out here a bit, saying I'm happy with the first step. So saying I'm happy with the blue box here of the workflow. And if I look at the model all over and I think I'm happy there, I'm ready to move on with the rest of the workflow. I'm going to go down here now to our D-Light section in the workflow. And once again, just the first thing I'm going to do right out the box is right click on the preview image and I'm going to queue that. So what's happening here is it's going to load or download the D-Light model that comes with this workflow, and it's going to grab our image and it's going to grab the mask that was generated, and it's going to try to remove as much of the lighting from the original image just so that we get a baseline texture that can then be relit. So if I bring the original image once again down here, just so that we can compare side by side, what you'll see is that we get the same image, but the model attempts to remove the lighting as much as it can. Pretty successful. Couple of things to keep in mind. Let me just fix this and put it back into place. So there's an important note here that says the level of the background affects the D-lighting a lot. Fully black generally doesn't work, and too dark makes the images red. Fully white can be over bright. Adjust the background level to your liking with the mask value level. So that value level is here. So if you look at the solid mask node here, what this is telling you is that you should adjust this value here. It comes at default to, I believe, 0.5. I found good success at 0.8. You can just do a few tries. It's so quick to generate that you should just just be able to start maybe at a 0.3 and then go up until you find something you like. Okay, so with that out of the way, what you need to understand is that at this point, we're getting a preview image of our delit texture, and this comes out at 512 by 512. I tried finding a way of getting a higher resolution output from this node, but I wasn't able to. But what's interesting is that now that we're going to go into the texture side, that's where you have some freedom. And the next section is the render textures backdrop. So I'm going to go ahead and select both of these previews and get them running. So I have the first one running. I'm going to open my command line here at the bottom so that we can see what's going on. Okay, and once that's done, I'm going to go ahead and generate the preview of the second one. So as you can see, what's happening here is there's like a virtual 3D camera happening here, placed at different locations. And from there, it's extracting what looks like normal maps and position maps for our generated model. So I'm going to move on now to the final step here, the texture sampling. You zoom in here to the sample multi-view. What you need to do is make sure that you have your seed set to fixed, just so that you can troubleshoot and generate and make sure that nothing is changing every time you're generating unless you want it to change. So I have my seed set to fixed, and I just change it. If there's something I don't like on the texture, I just go up one or down, and then I just stay there as I go. Another change I make here is on the steps. I usually increase this from 25 to somewhere between 30 and 50. So let's just do 50 right now. Once this node is done, it'll generate a texture. So let me just grab a preview here for you, and I'm going to right click it and queue it just so I can show you what this specific node is doing. So you see what this node does is it generates the front, back, sides, and top and bottom views, but this time in texture form. So if you select one of these images, you can just cycle through them and look them through. And if you're happy, then you can just move on to the next step. If you're not happy, you have a few options. The main one being just changing the seed to something else, and then you can just generate it. And actually, it's important for you to know that the reason why I was telling you to keep seeds static or fixed here on the generate mesh is because you might want to do new iterations on the texture. But if you have this set to random or increment or decrement, the problem is that it's going to have to generate the new mesh, the delight. Everything needs to happen every time unless you keep the seeds fixed and then make changes where you need. Whereas if everything is fixed, then whenever you do a new texture, it's only going to calculate the texture, but the geometry, is staying the same. So when this node is done doing the orthographic images of the texture, what's going to happen is you have two options. You can either just resize the texture from 512 into something like 2048, or you can enable these guys, and I'm going to select them and do Control B twice. And what this does is this is just an upscale model. So it's going to grab the upscale model, grab that image, and then upscale it to 2048 as well, but through an upscale model instead of just stretching the texture in place. This will take a bit more processing time, but it's worth it. It's fairly minimal. So what you want to do here is you want to actually connect from here directly down, and you can just ignore this guy. So now that we have that there, I think I'm just going to queue everything just so that we let the workflow run all the way to the end. Here are those orthographic views of our model. And then what happens here is that our texture gets upscaled using whatever model you like. And then that output goes in. And then from those camera positions, and our texture gets sliced into a UV map, as you can see here. There's a couple steps that happen here once the texture is sliced. We have the first one, which essentially is just a slicing. The second one, which is doing a vertex in paint. Very difficult to see the difference, but if we look here to the center area, you see where we have the blacks, nothing is happening. Whereas we look here, we start getting a bit of chatter on some of those dots. And I believe what's happening there is that it's going to help with the final in-paint process, just so that it can sample more colors than just big swatches of black. Because in the last step here, what's happening is that it's going to fill in every single space where it doesn't find a texture, and it'll just expand those pixels outwards, which makes us arrive to something that looks like this. So a texture like this is what you're going to be getting along with your model. Once we have that, it's going to grab model, it's going to grab our texture, and it's going to put the two together. And then from there, you're going to land into something that looks like this. Let me turn off my console here. So now we have a model of our image, and something like this took me just under 3 minutes to run. So if I hadn't been stopping over every single step, if I just input an image and I let it run, it takes just under 3 minutes. And again, you have some freedom here in terms of how you want to view this model. So you can turn off the grid, you can change the background color if you like. You can actually add an image if you wanted. I don't see the need for that right now. And then you can just switch here, and then you can just see normals, or you can see the wireframe, you can see the original again, or you can just change the lighting, which is pretty interesting. You can just increase or decrease the light intensity. And the cool thing about this is that, while yes, this texture is not perfect, the model is not perfect, it's for very specific use case. There is a ton you can do with this. And what's cool is that because this already has an unwrapped texture, we can just grab this texture and we can just paint it ourselves. It's easy enough to do. However, just like last time with Trellis, what this outputs is a GLB file. So there is a modification or just an addition you want to do to the workflow, which I've done myself. I do keep the GLB because I find it helpful to be able to see the preview here with the texture embedded. But what you can do is you can just make a copy of this node like I've done here below, and then you can just select from the dropdown whatever file format you're after. For us in VFX, one of the most useful ones is an OBJ, so I select an OBJ. Make sure you set the save file to true, and once you do that, you're going to be getting not only your GLB, you're going to be getting your OBJ and your texture. Now in Nuke, what I'm going to do is I'm going to select my OBJ and I'm going to select my PNG. And you see we have our texture here and we have our model. And what I'm going to do is I'm just going to plug in the texture into my model. Once you're here, because the texture is just, a regular PNG, you can actually come in here and you can paint and make adjustments to the textures as you see fit. The layout is of course not perfect. This is just done very procedurally in the background, but there's still a ton you can do. So you do have access to that. However, if you're happy with the texture as it comes in, then great, you just have an asset and you can place it and you can do with it as you see fit. That covers the first workflow, which uses just one image as an input. So now I'm going to go ahead and grab the second workflow and I can show you how they differ. This is the multi-view version of the workflow. And what differs here, even though it looks a lot larger, is that everything here at the bottom remains the same. Basically everything here in the middle remains the same, but this section on the left, it's what changes a bit. Before, we were dealing with just a single image input, whereas now we have up to 4 inputs here. So you can see we have front, left, right, and back. And of course, you don't necessarily need to have all 4 views to make this work. I believe the workflow by default comes with one of the views disabled. So if you don't want to use one of them, all you need to do is select all the way up to the join image with alpha here and make sure you either disable or mute those nodes so that they get ignored when we go into the mesh generation process. So what happens here is more or less the same. It just happens more times than just the one time. Once again, no matter what you put in here, all these images will be treated as 518 by 518. And what I've done here is I took a few pictures of a sculpture. So you see I have the front, one of the sides, the other side, and the back. And what's interesting about this workflow and why it is so much nicer to use this one instead of the single image one is because when you look at an image like this, the model has to guess everything that it can't see. Whereas a multi-view, you're telling it exactly what every single side looks. And yes, there are limitations because I'd like to have at least 6 inputs so that we could also cover top and bottom. But the jump from 1 to 4 is already huge. So it's definitely worth working with this workflow if you have more than one reference image. So again, resolution will be taken care of on all of these. They all have the image, the background remover. So if I cue some of these, what you'll see is that we have our image and then the background remover does its thing. So I'm gonna cue all of these just so that we can see that they are all working, just so that we can go step by step on the workflow. And you can see very quickly we have our images. They've been resized to 518 by 518, making sure that nothing's cropped from our images, and they have now their backgrounds removed. A bunch of notes here on this workflow where you can find the models you should be downloading. And now that we have our images coming in with their masks already attached to them, I'm going to go ahead and preview these 2 nodes here. So preview this and preview that. This is going to go in and generate previews for those images. So there we have it. That way we know exactly what's coming in. And this is for us to check that everything is working so far. So far so good. Same notes as the previous workflow with things like the octree resolution and the max number of faces. So all of that information remains the same. The nodes are exactly the same as well. So you can just trust that whatever you're doing for the single one, you can apply for the multi-view. And I'm going to go ahead and right click here on the preview 3D. And I'm going to let that cook for a second so that we can see what this model looks like with our 4 input images. That took 23 seconds to complete, and you can see, let me bring in one of the images here just so that we can compare side by side. What we have here is a pretty decent version of our image in the form of 3D now. And because we gave it all that information of what things look behind and front and on the sides, I think it's pretty accurate. Whereas if you just gave it a front view, and if we look at the back view, what you'll see is that it has these nubs on the back of his head. And if I go to the 3D view, if you were to generate just with one image, it wouldn't, of course, guess it. Or I guess you'd need to get very lucky in order for it to do the proper guesswork to get there. Whereas we look here, it does have them. Maybe it looks like there's one missing, so I should be able to just go in, try a couple seeds, or maybe try and do a bit of a different angle and replace one of those images in order to improve my output. But for this, I think this is more than enough, more than I was expecting and way more than I was getting with the previous solution that I mentioned before, which was Trellis by Microsoft. I'm going to go ahead and move my image back to its place. Let's say I am happy with this preview right here. And because I think it is a successful generation, I'm going to move on to the rest of the backdrops here. So just like the other one, the D-light section remains the same. I'm going to go ahead and right click and queue that. And again, just like before, this is going to be grabbing those images and it's going to be removing the lighting as best as it can so that it removes any baked lighting that it's already on the textures, and hopefully from there give you a better starting point. Here are the results. Pretty decent. Not perfect, of course, but pretty decent considering what it's doing. You can, of course, adjust the solid mask value like it says here if you things are getting a bit too burned, or alternatively, if you're happy with the baked lighting just because it produces a better texture for you, you can just grab this node here and you can just hit Control B to disable it. And if I queue this again, what's going to happen is it's just going to give me my original images now with that baked lighting in. So maybe this is something that you're okay with because when you photographed the model, the lighting was correct to what you were going to be using it for. So you can always just turn this node off and that way you have your baked lighting. However, for me, I'm going to go ahead and re-enable this. And I'm going to queue my images again, and I'm going to make sure that everything is working correctly. Now that that's completed, I can go ahead and move on to the next step. So the next step is here, the render textures. And just like before, this is going to create the normals and the position pass. That's now complete. That looks pretty good to me on both of those passes. And you can see here, even though we didn't give it a top and bottom view, it does some guesswork, of course, and it tries to understand what it's looking at. You can see it even gave it that heel that you would expect from a shoe like this. So yeah, I think it's pretty cool. I'm going to move on from the render texture section into the texture sampling. And now, just like before, because I know my settings are fine, actually, I'm going to increase my steps to 50 here. And I'm going to select my upscale model and make sure I enable that, and change the connection so that it goes through an upscale instead of just the texture stretch. Remember, this is where the texture goes from 512 all the way to 2048, and you do want that because you want to have some more freedom when it comes to adjusting the textures yourself outside of Comfy. You can of course go higher. You can just go 4K if you need. For this example, I think 2K is just fine. So with that in place, I'm just going to zoom out here a bit and I'm going to hit run here for the whole workflow, just because I know everything else has happened and my seeds are fixed, so I can trust that nothing else is happening. And now it's going to be processing things, and once it gets here, it's going to populate the rest of the results. Now that's done processing, and I think it's important for you to know that this preview right here where we get the multi-view is where you can get creative. You can actually just save these images and actually paint them up and improve them where you see fit within or outside of Comfy, and then make sure that those new images get plugged in into the rest of the stream, and that's going to produce, of course, changes in your base texture. Just know that you're not married to just having to paint on something that looks like this. You can actually make improvements here, because from these images is where the splicing happens into our actual UV map. Now that that's completed, you can see we have a model here that, again, while not perfect, is way beyond what I was getting in the previous solution. And you can see there's some issues here around the eyes, maybe around the mouth and the hand. But again, I would just go ahead, grab a different seed, try again, grab a different seed, try again. And if that doesn't work, I can either paint some of these issues by hand, or I can just maybe take new pictures of the asset, right, at a slightly different angle where I see issues are happening. And that should provide me with enough coverage for me to get something that looks correct. I am pretty happy with this. I think it's a triumph to get here with such little effort, and that from here, this is just a starting point for a lot of things that you can do with it. Just like before, this is only saving a GLB file, which you want to go ahead and do, just like on the other workflow. Let's make a copy of this, save it, and then change this from GLB to OBJ. Make sure the save file is true. And if at this stage, let's say you ran everything and now you're regretting not having turned on the soften normals here in the post-process mesh under the blue backdrop, what you can do is you can just grab this node, and if you go here to the very end, let's say I'm going to move my preview here to the right. I'm going to bring a copy of the post-process mesh node. You can just select this, connect it here. Actually, not here, sorry. You want to move this here, and you want to grab the output here of the applied texture into here, and then this goes here. And now you want to turn everything else off, and now you can just turn the smooth normals, and that's going to generate is the exact same result we have right now, but with softened normals. Just know that you have the option of doing that at the very end. So maybe you regret not having done it up here and you don't want to run through the whole workflow. You can just add that node here again, enable soften normals, turn everything else off, and you should get that new result. So hopefully you see how this is incredibly helpful as to how you can do something very quickly. You can use this for pitches, concepts, background assets, and so much more that I urge you to set up a Comfy UI specifically for this workflow, because I promise you it's going to come in handy. Hopefully that helped you more or less navigate and understand why there are two workflows, what they do, what you can achieve with them, and the amount of flexibility you have with something that's going to take you minutes and it's going to help you block out a scene or a concept very quickly. Keep in mind that this is just the starting point of this workflow. This is just for you to get an output very quickly. But if you spend some more time improving the workflow, there is so much you can do. Hopefully it was helpful. Hopefully it wasn't too complicated, and it's something that can help you in the future. Until next time, thank you for watching and stay curious. Cheers.